Welcome to Part 8, the final part of our training series, Introduction to OBD2 and Electronic Vehicle Diagnostics. In this episode, we're pulling together everything with a general overview of fault codes and the fault-finding techniques. Fault codes in general. A fault code can indicate the problem area. It doesn't necessarily indicate the fault. Some fault codes can be very specific about the nature and location of a fault. However, many are less specific and can be activated because the signal in the circuit is implausible. The fault could be related to a wiring or connection fault, a sensor or actuator fault, or another type of fault applicable to the system. A fault code may be actuated because the response of a sensor or actuator is not correct due to a fault with another system. The most common one is with oxygen sensors. For example, a small air leak in the exhaust system can cause a significant change to the oxygen sensor signal. Vehicle manufacturers use different terminologies for components, and also different systems may share the same terminologies or names. For example, some fault codes refer to a power steering control circuit, and because they are different types of power steering systems, the fault code could refer to different control systems. For a mechanically driven power steering pump, the code could be due to a pressure control valve. In a system with an electric pump, it could be due to a relay or sensor. So it is necessary to identify the components of a system and the wiring in order to diagnose the fault. In other words, if you're not familiar with the system, you must refer to vehicle-specific information, like workshop manuals. So, you must understand how a specific system works in order to properly diagnose it. This slide shows typical additional information available with a VW fault code. Take note of the additional freeze frame data, fault status, and fault priority. The fault above tells us that the electronic control module has detected the N205 circuit on bank 1 has been or is shorted to ground. Diagnosis will require an understanding of the N205 function and the circuit and the way it's connected to the electronic control module. The diagram shows the schematic location of the N205 sensor. The circuit diagram shows the location of the N205 and its wiring in the circuit. In the wiring diagram, you will see the N205 has battery voltage to it on one side with the key on, and the ECM is the source of the ground when the N205 is activated. The electronic control module is actually monitoring this circuit when the N205 is not active, for the battery voltage that will travel through the N205, and if there's no detective voltage, rather a grounded circuit, this fault code will set. So you'll need to check for the following: the fuse or power, wiring and connections, a failed N205, or a failed electronic control module. In this case study, two faults are present. P3081, note that this fault code does not contain the word circuit. This indicates that it's probably not related to a sensor failure. This is most probably due to a thermostat failure. The next code, P0332, the word circuit indicates a probable sensor failure. The course of action would be to test the sensor. In this specific case, it was found the wire on the NOx sensor on bank 2 was loose. In this case study, both fault codes do not refer directly to a specific sensor. However, if we consider the position of the sensors, we realize that the only sensor ahead of the throttle valve is the MAF sensor. In this case, the faults were caused by a dirty MAF sensor. The following is the generic diagnostic procedure. First, use a suitable machine to read the fault codes. Try to determine which system the fault code lies in. Research the system to understand the way it works, and use this to interpret the fault code. Check the live data for the plausibility of sensor values, Then test the sensor and test the wiring as required. Always check for other fault codes or fault codes in other control units. They may seem unrelated, but it's often the case that one code refers to a symptom, but another code can indicate the cause. Always check whether a signal is part of a CAN bus system, as signals are often shared between control units. For example, the signal from wheel speed sensors can be used by the ABS and traction control systems, but also be used by the transmission and engine control systems. Always check for mechanical faults. A common example is the camshaft-crankshaft position sensor error, which can be caused by a slack timing belt or chain. Try to check sensor values with other tools if possible. Check live data values for plausibility. Do the read values make sense? Don't assume that a code definition is the final answer. Don't assume that all OEMs use the same code in the same way.